Hello there. In this lesson, we're going to learn about electric current. So you can see two images on this first slide. One has a little bit of water coming out of the tap, and the other one has quite a bit. So this is an analogy to what electrical current is like. So you can think of the water as being like electrons, and when there's a low amount of electrons, this would be like a low current. And then if you got lots of water, that's equivalent to like lots of electron, and this would be a high current. So we're going to learn about electrical current today, and in your head you can keep the analogy of it being like water, and that'll help you along the way. So in order to quantify the amount of electrons that are flowing through a circuit or a device, we need a unit. So with water, you might choose volume. You could say that maybe coming out of that tap, there was, 100 milliliters per, minute or second. And so that would be useful to quantify the current of water flowing in a pipe or flowing out of a tap. So we need something similar for electrons. And so the unit they use for electrons is the coulomb. The coulomb is like a milliliter. It's a unit that measures a certain quantity of electrons. The symbol is C. 1 coulomb is this giant number of electrons. It's similar to like 100 milliliters would be a giant number of water molecules. Because electrons are so small, you measure them in big bunches. You don't have to memorize that number. Just know that it's a big number of electrons, and that equals 1 coulomb. If you're going to use it in an equation, which we will later on, the quantity is called charge. The charge is measured in coulombs, and that's how many electrons you have going down a wire or through a load. And the symbol that you use for charge in a equation would be a Q. So there's a bit of language to get used to and different symbols that don't always match the word. I'm not sure why it's a Q for charge. At least coulomb matches the C for the symbol. So to measure electrical current, we need a device called an ammeter. So an ammeter can be hooked up into your circuit in order to determine the flow, how many coulombs, how many electrons are going by a given point every second. And so the fancy word for a coulomb passing per second is an ampere, right? An ampere is 1 coulomb per second. And so you can see on this multimeter here, it can be used as an ammeter if we hook it up. We aim the dial towards where there's an A. And you also need to hook up the sockets at the bottom here using this socket here with the A in the socket. So this is a multimeter. It can do multiple things, but it can also act as an ammeter. Okay, I'm not sure why I'm still in blue here. So when you're going to use an ammeter, you have to hook it up so that the electrons flow through it, so it can measure the flow of electrons. And so that means hooking it up in series with the device that you want to know the current about. So in order to determine the current of this light in this circuit, you need to put the ammeter into the circuit so that you can measure the flow of electrons going through the ammeter and then back out and through the rest of the circuit and back to the beginning. To illustrate that as a circuit diagram, you can use an A in a circle to represent the ammeter. And so we could put our ammeter here. As long as it's in series with the device that's being measured, we have to switch over here. Then it'll work just fine. So it has to be in series, and then it'll work. So when we're calculating this from measurements, one good thing to remember is that since we're talking about the amount of electrons going by a given point per second, you can think of microscopically, you can imagine that these little red dots are electrons. And you can imagine that the larger ones here, those are the atoms of, say, copper that make up a wire. And so the electrons have to find their way in between the atoms along the flow of the wire. And the quantity that goes by every second can be used to determine the current. So an ampere is one bunch of electrons, 1 coulomb of electrons going by every second. And we can calculate that if we measure the coulombs and the time, or if you have, of course, one of those devices as illustrated earlier. So here is a relationship between all the components that go into measuring current. The symbol for current, it's another one of these ones that doesn't match the word, is an I. And so if you want to make yourself a triangle that you can use and rearrange, 1 unit of current is determined by dividing the charge, which is Q, divided by the time, which is going to be in seconds. So some new symbols to get used to in this section of our course, but it all works. There's the same basic math, and you can always make a triangle. You don't have to memorize these formulas. We'll always provide those. Okay, so we're going to use that relationship to work out the current here. So current is I, and we're given 30 coulombs, which is Q, and we're given the time, it's just 6 seconds. So I equals Q divided by T, as given in the formula there. And so we got 30 coulombs divided by the 6 seconds, and that's going to leave us with 5 what? 5 amps. Let's try a couple others here. You can always make your triangle out of this if you want to keep things easy for you to rearrange. So this time, what is the charge? We're looking for Q, given at a point at over 5 seconds. That's time. Current of 9 amps, and that's your current. So we're looking for Q. Q equals I times T, and so we'll put in the current 9.0 amps times 5.0 seconds, and 5 times 9 is 45 coulombs. Great. How long must a current of 12 amps run in order to move 240 coulombs of charge? So this time we want the time. So time equals the charge divided by the current. And so we'll take our 240 coulombs of charge and we'll divide by the 12 amps of current. And it looks like that'll be 20 what? 20 seconds, which is the unit of time.